Okay, this video is going to contain some hints and tips for completing your final project in cs151 Intro to Computer Science. So I have the course website here pulled up, and we have clicked on the Final Project tab. And the final project is all about data stores. A data store is basically just a place for you to store data, as the name implies. Okay, we're going to use CSV files for our data stores. CSV is comma separated values. We've discussed those in previous lectures. Basically, in this final project, there are 4 little programs you need to complete. Okay, the first program is DS, which stands for data store -print.py. Alright, and then we're also going to be creating some CSV files, and those files are going to be our data stores. Okay, so that's the first one, and ds-print.py, dsprint, this basically just takes one of our data stores, if it already has some information, and prints it out in a nice way, a human readable way. So this is an example of what a CSV file might look like. Alright, this first line is the labels. So here we have the first field here is last name. So on every single one of these lines, each line is a record. Each record contains data about one entity. Okay, in this case, this is the customer's data store. So this is one customer entity. Alright, so this is one record of the data about one customer. Alright, the very first line in the CSV file is the titles for each of the fields. Okay, so this first field is the last name field. So this is the last name of our customer. In this second record, this is a different customer. This is the last name of that customer. This is the last name of the third customer, etc. So then we see the first name is the next field. So that's the first name of the first customer, first name of the second. Here we have phone number. So this, again, this first line is just the labels for each of the fields. And here we have phone number, and then we have email, and then customer ID. Now for customer ID, it's important that IDs are unique. They identify. Okay, so if you have an ID that's different, then you can uniquely identify every single customer. However, if you have an ID that's the same for 2 customers, that can be a problem, because you go to look up one customer by their ID and it identifies 2 customers, and that's not what we want. So IDs should always be unique. And what we've done here, this is an ID number known as a UUID, Universally Unique Identifier. These are very common in computer science, and there are several different versions. Go ahead and read this article and it'll talk about them. But basically it's just a way to identify one particular object, and it uses pseudo-random generators to generate a number that has a very, very low % chance of a collision. And in fact, you could make these UUIDs billions of times a second for hundreds of years, and the chances of a collision would be extremely low, like 0.00 something %. All right, so I just wanted to expose you to these types of IDs because you might see them. But again, all it is it's just some way to identify this record uniquely. Right up here, this is the customer ID. Each one of these is the customer record. All right. Now down here in Pet CSV, we have a different data store. So we have different labels. So the first label is the pet name. Second label is pet type. So we have birds, cats. We did old school Looney Tunes characters here. And then the customer ID and pet ID. So we have 2 of these UUIDs. This is the first UUID, and this is the second one. Now the pet ID should uniquely identify the pet. So every one of these pet IDs is different. You see that? Really, I should be highlighting the whole thing. This is the entire UUID. Okay, every single one of these is different. Now the customer ID on these pets, however, is the same for some of them. So for example, Tweety here is 1B61, and we see down here this is 1B61, and down here this is 1B61. Okay, that's because the customer ID is supposed to represent the owner of these pets. Okay, and if we look up 1B61 up here, 1B61, this is Miss Lovelace. Okay, this is her ID. So that means she owns all of these pets. Okay, so even though this is a separate data store, we can relate this data store with information of other data stores. So if I have a pet here and I have this customer ID, then I can look in my customer's data store, look up that customer ID, and locate which customer or get a phone number to contact that customer. All right. So this is how we link the two data stores together with this customer ID. They share this field. Okay. So in this first one, we're going to use these two CSV files, these two data stores, and all we have to do is just print out the data in an aesthetically pleasing way. All right. So let's go ahead and get started. Here's a complete version of the final. I'm going to go ahead and start from scratch. This first one I'm going to do for you. I've outlined pretty much everything in the lab anyway, or on the course website. I'm going to go ahead and finish it up for you so you can see it, and then I'll go ahead and do this last one too, the find. The find is by far the hardest one, but it's the most interesting, and this is the type of stuff you do in computer science all the time. You have to search through data. You have to format data in different ways. You have to get data from files, look through that data, organize that data, and it's critical to nearly every aspect of computer science. Okay, so that's why we're doing this for the final. All right, so let's get started. Number one, this is dsprint.py. Okay, so I have Atom opened up here on my desktop. I'm going to make a new folder and call this final. And if you look here, the path for this is supposed to be on the CS server in your home directory, and then make a directory called final. There was a typo in the grading previously where it said labs before this. There should not be in the labs folder. It should be home and then final. I'll count either one, but you get a bonus point if you actually put it in the right directory. Alright. So we have final here, and let's start going through this. First we need to create these CSV files. This is relatively simple. Just copy and paste everything. So new file. This is customers.csv. Paste, save. And then we have pets.csv. Copy all this. There was a comma at the end of one of these, which was causing some people some trouble. Sorry about that. Typos are a thing that happen a lot in computer science. Alright, new file. We have pets.csv. Okay, so here's our two data stores. They're just CSV files, comma separated files, right? That's done. We talked about the UUIDs. Now we need to create dsprint.py. So new file, dsprint.py. Okay, so eventually what we're going to want to do is we're going to take the file data from one of our CSVs, one of our data stores, and format it like this. Okay, this is not actual code that's going into our file, dsprint, but when we get done, this is going to be how we formatted all of the data. All right. So in the CSV file, we see customers. You have the field name on top, right, and then every single record. What we're going to do is make it like a Python dictionary, the field name, then colon, and then that value. So again, we have a list here. Notice the square bracket, that's a list. It's a list of items. Each one of those items, this is the first item. Notice the curly brace. The curly brackets are dictionary. That's how you make dictionaries in Python. So we have an open curly brace and a closing curly brace. In between those, we have the field names and their values. So this is the first field name, the key, and this is the value. The keys are always strings, and in this particular example, we're going to make the values always strings as well. But theoretically, you could have other values. Alright, so here I've given you some code to get started with. I've left some stuff out. Alright, So basically what we need to do is parse the data from the files into a list of dictionaries. Alright, so if we use the .split function, if we split over each new line, that means each one of these items, each one of these lines of text will be an item in our list. So that'll be one item, that'll be another item, and this will be the third item. The third item has an index of 2. The fourth item has an index of 3, right, etc. Okay, so let's just paste this code in one at a time real quick. So first, I didn't tell you how to do this part. I'm going to go ahead and fill that in, and we'll paste this first line. Ask the user for a path to the CSV file. Okay, so we know how to ask for input. Enter the path to the CSV data store. Okay, we're going to be reading data, so I'm going to say F for file, and since we're reading, it's input, so file in, and we're going to use the open function. What are we opening? Whatever the path they typed in. Open path, and then we're opening it for reading. Oops, fin.close. Okay. So we've read this data, but we have to store it somewhere, right? So it says here store contents in variable file data. So that's going to be what we call our variable. So fin.read, we've already opened the file. This reads in all the data from the file. So file data here is just a string that contains everything that was in that text file. Now we can get rid of those comments, and we can look here at this line, CSV lines. All right, CSV lines. We've taken the file data, we have stripped off the white space beforehand and afterwards. So that means if there's any new lines, any blank spaces, any extra lines at the beginning or at the end, any of that is stripped off. Okay, and then whatever's left, we split that over the new line character. Remember, the split function creates a list over this delimiter character. So if we could look back here at customers.csv, every time we go down to a new line, there's actually a hidden new line character here. There's a hidden new line character there, hidden new line character. So if we split this, all of this data over the new line characters, then this becomes the first item of our list. That's the second item without the new line. This is the third item without the new line. Okay, so let's just take a look at this and print it out and see where we are. Print CSV lines. Okay, so let's open up the terminal, CD desktop, and we are in final. Python 3, ps print. Enter the path to the data store. So let's look at customers. Okay, now we have here a list. This is the first item of the list. These are the labels. This is the second item of the list. Right there. That's the first actual record of information, because the first item in the list is the labels. Okay, so this is what the split over new lines has done. And again, this .strip just removes white space from the beginning. It's just a good habit to kind of do that whenever you're dealing with string data. Alright, so that's what CSV lines is holding. And let's go back and look and see what else we've added in here. We want to get the labels. Okay, so we need to pop off that first item in our list, right? So this first item here is our labels. So we want to pop that out. I've added the code on the course website. So this is CSV lines.pop 0. That removes the first item from the list, but it does two things. It also allows you, it returns that item. Okay, so I can, whatever was that first item in the list is now removed from the list, but it's also saved in this variable called labels. And then I also stripped off the white space. Okay. So we did that. Now we want to, this is just text data. So let's print this. This is just a string. Okay, we see this is just a string, it's not a list. What we want is a list. So we're going to use split again, and we're going to, which I have all of this here. And if you want, you could just start by copying and pasting this entire thing in here. That would probably be easier. But I want to show you line by line what's happening here. So now dot split converts this string into a list. When we run it again, we'll see the list version. Okay, now we see it as a list. Alright, the commas are no longer in the strings of each item. This comma is part of Python syntax. It's part of the list. It's not part of the string data. Here, the commas were part of the string data. Alright, back up. Okay, so for each line in that CSV list of lines, remember it no longer has the labels because we popped that off. So let's print out CSV lines again. Okay, so here, this is our list, and we see that the labels are gone, right? So everything in our list now is just customer records. Alright, so for each line in CSV lines, we're going to get one and strip off any white space. That's just a good habit to do. For line in CSV lines, line equals line dot strip. And then if the line doesn't equal the empty string, okay, the reason we're doing this is for like pets, the pets CSV, sometimes one of these lines will be empty. Okay, if it is, we don't want to try to create a record from that because there's nothing there. We only want to create a record from one of these lines if there's any data on it. Okay, so that's all that line is saying. So let's go back down here. If line does not equal, okay, so in this we have the colon, which tells us there's going to be indented code block. Sure enough, we're indented, just like in this for loop. All of this indented stuff is part of the for loop. Now this if block, whatever's indented, is part of that if statement, or the code block following the if statement. Alright, so if line does not equal the empty string, then we want to try to create a record. We want to make a dictionary. So we go back to our page. We want to get all of the values from this particular line. So first let's just print out the line. What are we looking at here? So for each line in our CSV lines, that's a list of lines, we're going to strip off the white space, and if the line doesn't equal the empty string, we'll print it out. Okay, so we'll do customers.csv. We're printing out each line here. This is printing out the entire list, and here is one line at a time. Now this is only interesting actually if we do, we don't need this print statement anymore. Okay. Now let's do the pets CSV file. Pets.csv. Now this one's interesting because this shows that we've gotten rid of all of those spaces in here, in this file. That's because of this if statement. If the line does not equal an empty string. If we remove that and unindent, then we'll see all the different spaces that we have, all of the extra blank lines. Pets.csv. See, we see the blank lines. So when we put that back in, this code now only runs if the line is not blank. So if the line is not blank, we want to create our dictionaries. So first we have to get our values from the line. The values are separated by commas, comma separated values. So we say line, and we're going to split that over the comma. Alright, and that's what we have down here, line dot split over the comma. And we want to store that. That's going to be a list of data. So we're going to store that list in this variable name that we just made up, and we're going to call that values. Alright, so now we're going to make an empty dictionary. So I'm calling that dictionary. The identifier I'm calling it is DI. I'm just making that up. It stands for dictionary. And for each one of the items in our list values, what we're going to be doing is taking one of those items from that list, but we also have a list of labels. Okay, so we have two main lists we're concerned with. Let's print them out. We have print labels, and then we want to print out values. Okay, so here's the list of labels. 1, 2, 3, 4, 5, and here's the list of one of our customer records. This is inside of this for loop, so that's running the one time through the for loop is these two lines. Then we look through the for loop again, and it's going to be these two lines. Notice the labels are the same no matter which time through the for loop you're in, but the values change. Okay, so for each line in our CSV lines, right, if that line has value, we create the list of values, and notice they match up, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 labels, 5 pieces of information. So I need to match these two things up in a key value store, so I can have a key to my dictionary and a value for my dictionary. So since there's two lists, I can't just do the common for loop, which is for item in labels, right? Because that would just give me, item would just be each one of the labels. What I need is the index number, so that I can use both lists. The index of this one is 0, and the index of that one is 0. Index of that one is 1, index of that one is 1. Index of that one is 2, index of that one is 2. So I can use the index to match them up. Okay, so instead of for item in labels, or values, or whatever, I can say I want some index value, so for I in, and to get the index, I can use the range function. So I want the range function to produce a list of numbers that are similar to indices of my list. Okay, so my list can have, it starts with 0, which is fine, that's what the range function generates. And I want it to go to the length of values. Okay, so length of values, let's see, in this particular database, or data store, we have 1, 2, 3, 4, 5. Okay, so length of values is going to be 5. So range is going to produce a list-like object. Let's go to Python 3 and show this. Interactive mode. We want a list version of range 5. This produces a list starting at 0, going all the way up to 5, but not including 5. Okay, so here's this gives us the perfect list for our indices. The first index is 0, 1, 2, 3, 4, and then that's it. Right? That matches with this. 0, 1, 2, 3, 4. So that's perfect. So this is how you get the index value of a list. So I, each time through this loop, I is going to be the index starting at 0, and it'll go all the way to 4. So that means we have a key is going to be in our labels list, the item at index I, and then our value is going to be in our values list, the item at index I. So we're using the index to match them up. So key is going to be labels 0 first time through the loop, which will be labeled 0. So the key will say last name. It will be the string last name. And then first time through the loop values, since I is 0, values will be the string Loveless. Alright. So that's a key value. Since we have a key value now, we can add that to our dictionary. Alright, so our dictionary, we use the key. This is a string. Remember, the keys to our dictionaries must be strings, at least for, they don't actually have to be, but to make things simpler, that's the way I've described it to you so far. So the keys are strings. Alright, and then we set the key equal to the value. Okay. So now we're going to print out our dictionary so we can see what we've created. So we run it again. Okay, here's our labels, here's our value, and here's a dictionary. Notice we have now matched up value, or label to value. So label to value, and then first name, value, first name, value, right? Phone number, phone number. Okay, so we matched them up, and now notice the curly brackets, we have a dictionary. So what we want to do with this dictionary is add it to our list of dictionaries. Okay, so that is this data list here. This will be our list of dictionaries. So we make an array, and we're going to add these items to each one of these dictionaries that we create. We're making one dictionary for every customer record, and we're going to say data list dot append the dictionary. Okay, right there. So at this point in the program, we've read the file, parsed it, and what we want to do is we want to print everything out in a sort of aesthetically pleasing way, right? This dot 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 means you would print out all of the customers, but I didn't want to take up all the space on the page. Okay, so we want to mimic this output. Okay, so first of all, let's get rid of our extra print statements that we don't need anymore. And we might add a little something here. This is where we're printing out okay, so now we've already constructed everything. This is the parsing. We read the file, and then we parsed it into a list of dictionaries here, and now we want to print it out nicely. So first, let's just print out our entire dictionary, or our list of dictionaries, and we'll see it's a list of dictionaries. Run that. Customers.csv. Okay, so we see we have a list, square bracket here, and then the first item of that list is a dictionary, this dictionary, and see there's key, value, key, value, key, value, right? The second item is a dictionary, etc., and at the end we have a square bracket that shows us our list is completed. Alright, so we have a list of dictionaries, that's what we want. Now we need to iterate through that and print things out nicely. So for key in, how do we get the keys of a dictionary? Well, first we need to, we have a list to start with. First we need to get each item in that list. Each item is a dictionary. Okay, so we have a list of dictionaries. So for each item in data list, each one of these items is going to be a dictionary. So we'll print that out to prove that. Item, and then we can print out type item. Okay, so we have one dictionary, and then the type of that is DICT dictionary, right? This is the next one, and the type. Okay, so each one of these items this item variable, is actually holding a dictionary. So to get the keys from that dictionary, for key in item.keys. Remember that from our dictionary lecture. Item.keys returns a list of all of the keys, all of the key names in this dictionary. And let's just prove it by printing out the key name. Okay, so this would be for the first customer, the key name, last name, first name, phone number, email, customer ID. Then that's this outer loop here. That's one time through the outer loop. Now we're at the next customer and we have the same information. That's the second time through this outer loop. Then we have the third time, fourth time, etc. Okay? This inner loop is the thing that's making the individual last name, first name, phone number, email, customer ID. Alright, so each one of these each time through the loop, key holds the key to one of our dictionaries, our dictionary values, right? So our dictionary is item, and there is a key inside of that dictionary. That's the string value key. Alright, so I say item, square bracket, key. That should access a value in our dictionary. Remember, item is a dictionary. To access the items in a list, you use reference by index, and that's square brackets and then a number. With dictionaries, it's reference by key, and it's square bracket, and then you insert a key in, or a string value inside, or something that evaluates to a string, right? So I could do something like this: first name. That would access the first name property, right? But since key, first time through the list, is last name, second time through the list is first name. So instead of actually putting a string in there, I can put the variable that holds the string. Okay, so now I have a key and a value, and I want to print out key value. I called it val. There we go. So this is a variable that I just made up. That's the identifier name is value, and this holds the value of this dictionary. So there's the key, and then there's the value. Alright, so that's not the exact format we want. We want, first of all, there's no spaces between each individual record. Second of all, we want the key, and then a colon, space, and then the value. So we need to fix that. So we want key, and then we want to add a colon. So we'll do that. There we go. Key, colon, value, right? But now these are all kind of mushed together, and it's hard to tell, which customer is which, right? So what we want to do is each time through the list, let's just print a little space out before we print anything else. So when there's a new customer, a new item from our list of customers, we could even call this customer. So customer, right? The problem with calling it customer in this is we're going to use different types of data stores. But in this particular example, we keep using customer data store, which we specify at the beginning. Customer. Oh, customers.csv. There we go. Alright. So we could call that customer, but the problem is we don't know what's inside of each one of these data stores. Like we have one that's pets, so CUST doesn't make much sense there. So we're just going to call it item so we can use it for any data store we encounter. Alright? But this print is just going to print a blank line before we print out each one of these records. And let's try pets.csv. And sure enough, each one of the pets now prints everything out nicely. Tweety, bird, right? So you can see this is one of our records, second record, and you can look at this a little bit easier. It's easier on the eyes for humans anyway, okay? So that's all there is to the first one, essentially, right? And you can use this one as we go through and test the other stuff. All right, so for part 2, I'm just going to pull over the stuff that I have from another folder that's already completed. I'm not going to do that one for you. That one's pretty easy. Basically what we're doing is creating our own data store of whatever type you like. Okay, so we want ds create, and I'm going to move that over here to this folder, and see here we've got ds create. I'm not going to click on it so you guys can't see, but basically ds create just creates one of our data stores. What does it take to make a data store? Well, our data stores are just these CSV files, and essentially a data store is just one of these files with the labels at the top. If it has no records, that's fine. So like this is an example of a valid data store. It just doesn't have any records. We know what types of data are in it though. We know that the first item is a last name, the second item is a first name, the third item is phone number, fourth is email, and fifth is customer ID, right? So we know what type of data is stored in it, but there are just no records yet. Okay, so what ds create does is creates this sort of thing. It creates a CSV file, and it gives the first line of information. So basically what types of data is going to be stored on each record. Alright, so let's go back and create one of these. If we look at the course website here, we want to create exams.csv, and we want a student name, and then exam 1, exam 2, and exam 3. Okay, so ds hyphen create should do something like this. Python 3 ds create. Enter the path to the CSV data store. So we want exams.csv. Okay, so this is what we're creating. And then we just add field names. Student name. Then we want exam 1, exam 2, and exam 3. And then just press enter to quit. Alright, and that's all the output your program needs. If we go back in here and we look, we now see we have an exams.csv file here. And sure enough, what does it consist of? It's just the CSV file, and it's got the labels for the content. There is no content yet. We haven't added anything, but this is basically a data store. And so we can use this file to create any kinds of data stores that we like for whatever purposes. Alright, so this is a generic way to create data stores. So that's all well and fine. We can create the data stores. Here's some information on that. Let's skip over that, and we're going to add a record to a data store. Alright, I'm not going to do this one for you either, but I'm going to show you how it should work. So basically, once you have a data store, like this exams.csv, we want to add data to it. Right? I want to add multiple records. Customers.csv has multiple records. Here's 1, 2, 3, right? So we want our exams file to have multiple records. Right? So we're going to, I need to transfer over that file real quick from the completed section. ds add. Alright, so now I run Python 3 ds add. And what is the name of the data store? Exams.csv. And enter the data for, now notice it opened that file and it grabbed that first label. And it's asking me to enter the data for this label. Okay, so it knows, because we already created the data store and the data stores have the labels, it knows what to ask for. Right? It just uses that label and presents it to the user. Enter the data for label. Student name, this is Bob. Exam 1. Okay, and then it stops because it ran out of labels. Now this should work on any data store. If I wanted to add a customer or a pet or anything like that, any data store that I've created, this DS add should work on any of those data stores. We've made it generically so it works on all of them. And that's kind of some of the power in computer science. If you write things generically, you can use them in a number of different cases. Alright, so let's look at exams.csv, and we see that Bob has showed up under student name. We see his first exam was not so good, but he studied. Second exam better. Third exam even better. Right? So let's try that again. We can add another record. Alice. Oops, that was the CSV data store. So that's exams.csv. Student name, Alice. Alice is very studious. 97.5, 94.6, 98.7. Alright, and if we look down here, we see Alice is now a row in our data store. Okay, so we've added items to our data store. So that's good. And let's do this last one. Find is kind of a tricky one, but this is important that you understand how to do this. The reason we have these data stores is we need to be able to locate this information on demand. So if I need to find something, for example, if I have customers and pets, if I need to find how many pets that I'm treating in a veterinary clinic that are cats, because there might have been some bad cat food going around, I want to call them and warn them not to use a particular type of cat food. Okay, so I have to look up in my data store for all the cats and find the customer IDs, right? And then use those customer IDs to locate my customers, and then I can get my customers' phone numbers and call them and tell them not to use a particular brand of cat food because it might be exposed to some sort of toxin or something like that, right? So this is extremely common in computer science. It's relating data to other data. Alright, so let's get started on this one. New file. We have dsfind.py. Let's just copy and paste all this. Basically, we can just copy and paste everything from dsprint. We're doing the exact same stuff. We're opening a file, we're parsing the data, and at the end we're printing out the data in a human readable form. The only difference is in between we're going to look for matches. We need to search that data. So this is the part of the code that actually searches that data. Alright, so let's just take everything in dsprint and so this is the parsing. And then down here is the printing, right? So let's just take everything in this file and move it over to dsfind. Okay, we're doing the exact same stuff. We ask for what data store you want to find something in. You open the data, you parse the data, which we already did in dsprint, and then at the end we're going to be printing out data in a similar way too. It's not exactly the same way, but we're still going to leave this alone for now because we're going to be doing something very similar. Alright. So basically what we want to do is copy this code here. This is what we do in between. So this is our search. Okay, so just copy and paste this code from over here. It's not entirely complete, but it gives you an idea of what to do. So first we need to get a file path from user. We got all that up there. Open the file, parse the data. And now we need to, this is where we are. We need to ask the user for a field name. So basically in each one of these fields, we need to know which field to look in. Alright, so if I do Python 3 ds print pets.csv, oops, pets.csv, there we go. For each one of these field names, I need to figure out first which field am I searching in. So I want to look at pet type so I can find all the cats, right? This is just one example, but I might want to look at customer ID, or I might want to look at pet name and see which pets that I have named Lola or whatever, right? So when I'm asking the user, I want to ask what field of data do they want to look into, right? So I can say I want to call that variable user field, okay? So I can say user field equals input which data store, or which CSV data store field would you like to search in? And I can probably print those out too. Print so the fields are basically the labels. So f in labels okay, so f is just a variable name that I made up. It's going to be each one of these labels, and I'm going to print out each one of these labels. And then I'm going to ask them which CSV data store field would you like to search in. So this is the field names. And then we can comment all this out for now, and we can run it and test it. This is ds find, and we want to look in pets.csv. So fields. In this particular data store, we have these fields. Which data store field would you like to search in? I want to search in pet type. Okay, so that gives us the field name, and then we need to ask them for a value to search for, right? What search term would you like to use? Okay, so now we're going to search for some particular search term, right, in that data field. So in the data field, pet type, I want to look for cat, right? And then here's where all this comes back in. I have matches. So I want to go through all of my records, all of my items in my data list, so I'm calling those a record. That's one individual record. So for each record, so this is going to be a pet in the case of pets.csv. This will be one pet. Okay, so if the user field they specified is in the keys of that dictionary, so if this exists in the dictionary, which it should, but it might not. They might not type in the right thing here. So if they typed in one of the things I listed out, then we have, I want to get that data from that dictionary field. Okay, so if user field was cat or pet type, okay, value becomes whatever value is stored there for that particular pet. So here, pet type for this customer, or for this pet, is duck. Here, pet type is bird. Sylvester, the pet type is cat. Okay, so value, here we go, value is going to be the value of that dictionary at that key. Alright, and so our user search is what are they looking for. If I typed in cat here, so if cat is in that value, then that's a match. So I have my matches list, and I match, and I just append that whole dictionary. So this is going to be a list of dictionaries, just like in dsprint, but it's only going to be a list of dictionaries that match. It's not going to be the list of all of the dictionaries in the data store. So this then will print out, we want it to print out all of our matches. So data list is all of our data. Instead, we want to print out our matches. Alright, so let's take a look. Let's see how this works. dsfind, let's look in pets.csv. So we have pet name, pet type is what I want to look in, and I want to search for cat. Let's see, we got an error. User search is not defined. Oh, I misspelled that. Okay, so this is important, the error messages, right? dsfind, line 49, it tells you where to look. And it says whenever something is not defined, there's a good chance you made a typo somewhere, right? So this is search. Try that again. Pets.csv, pet type. What search term would I like to use? I want to find cat. And you see it's found matches, and it's found 2 matches in our data. Pet type cat, pet type cat. So this veterinary clinic has 2 pet clients that are cats. Alright, on each one of these I can use the customer ID. I'll copy that, and I can locate that in my customers database or data store. So dsfind customers.csv. I want to look in customer ID, and I want to use that ID. And I found the owner. Now I can give them a call and say, I'm sorry, don't use this cat food. Just calling just in case you are using it, right? And then I can look back up at my other customer ID, this one here. I can use my data find again. I'm going to look in customers.csv, and I want to look in customer ID and paste in that ID. Oops. And that's our other customer. I have a phone number for that customer. I can call them and warn them. Okay? So the print and the find are definitely the hardest. So I've given you a start to finish on those 2, and you should be able to do the others. Alright? So this is towards the end of the week, so hopefully you've at least tried a bunch of this. So this will give you a little boost if you've gotten stuck on anything. Alright? So that should do it for this video.